Okay, now in this video we'll see how to design a DC voltage for a constant 5 volt, so from a 230 volt AC signal. So I want to get a DC 5 volt constant using 230 volt AC, so having a frequency of 50 Hz for the AC signal. So since the DC voltage required is 5 volt, so one of the component that is required is, so I need to have a regulator which is 7805, and since I want to convert from AC to DC, so I want to use a half wave rectifier, one of the possibility, or I can go for full wave rectifier, or I can go for a bridge circuit. So in such case I need to use either one diode, or I need to use two diodes, or I need to use four diodes. So these are the requirements depending on which rectifier I'm going to use it. Next, the third one is, so I need to use a capacitor because I need to get a constant 5 volt, so it should be regulated at 5 volt. So I need to use a capacitor. So I need to design what should be the value of this capacitor. So this is the design part, and then afterwards I need a transformer. So I need a transformer which is of step down type. So I should find out what is the rating of the transformer. So this is rating of the transformer. So these are the things that need to be finalized before we start using this particular regulator for getting 5 volt. So we can certainly start writing the circuit diagram and then try to find out the value of C and the transformer rating, so that you can end up with. So let us start with one of the choice. Suppose if my choice is half wave rectifier, so let us write the circuit diagram. So we know that the half wave rectifier to get 5 volt is something like this. This is my circuit diagram. We're going to have the primary of the transformer. This is the circuit. I'm going to use, of course there is a capacitor required here, and I should have a 7805. This is 7805, and of course this acts like ground for this is 230 volt 50 Hz AC signal. I should use a diode, and this is my capacitor, and this is 5 volt. To get this constant of 5 volt, let us assume that this 7805 requires a V input minimum. That is, when I just say V input minimum, this is V input minimum required at the input should be, assume that it should be more than 7 volt. So since you want to have minimum voltage as 7 volt, let us assume that let us take it as around 20 to 30% more than that. So let us assume that input at the regulator, let it be 10 volt. If it is 10 volt, it is guaranteed that you are going to get 5 volt, because this 10 volt is more than 7 volts. So now you are supposed to get an input voltage which is 10 or more. It cannot be less than 10. So let us try to see what is the type of waveform you may get at point A. So let me say this as point A or node A. This is node B. At node A, so I know that this is my input waveform, the sine wave. This is my sine wave input waveform, and since I'm having a filter, so I'm going to end up with, this is my first cycle, and then it goes like this. It again picks up and then comes down. So this is the type of waveform that I may get at node A. You can see it is keep reducing, it goes up, and this is with respect to time. Of course, if you have one more cycle coming up, then it again goes up like this. So this again goes up and then it comes down. Now this is the input voltage that is over here. This is my V in. Let me just say it as, this is node some X. This is at X, and this is the voltage at node A. And we assume that the input voltage should be more than 10. So let me just take this as the point corresponding to 10. So this is 10 volt. This is 10 volt. Okay, let me assume that this voltage should be always more than 10. For this is we assumed it to be 10. Okay, this is if this is 10, okay, this is what is minimum required. Let me have it slightly more than 10. So let us assume this as 11 volt. If this is 11, then let me just take this as around 12 volt. So what is this 11, what is this 12 volt? Because we know that between 12 and 11 we have 1 volt drop. Shall I say v ripple is equal to 1 volt, because this is what is ripple voltage from the ripple of your, that is peak to peak of this voltage at A is nothing but the ripple voltage. That ripple voltage is 1 volt. Suppose if you want to know what is the expression for the output voltage at this point, so what is the expression for the output voltage? It is Vp minus Vd on is the expression at this point. So Vp minus Vd on is the expression at this point, which is equal to 12 volt, which is equal to 12 volt. Of course, what is Vp minus Vd on minus V ripple? So that's equal to now if I say Vp minus Vd on minus V ripple, this is equal to actually 11 volt. So from this we wrote, okay, V ripple is equal to 1 volt. So if you assume Vd on to be 0.6 volts, can we find what is Vp from this? So then Vp happens to be 12.6 volt, meaning that the voltage at this peak should be 12.6 volts. So this is what peak voltage. So from this I can get to know what is Vrms, which is nothing but V peak by root 2. V peak by root 2. So which comes out to be, it is 12.6 divided by the root 2. You can see it is now 8.9 volt. If it is 8.9 volt, then I'll be getting this as, okay, 12.6. If it is 12.6, then with minus 0.6 I'll go to it as 12, and with the appropriate capacitor it can give a ripple voltage of 1 volt, which will come down to 11. You can see at any point of time at this point the voltage never goes below 11, so which is always more than 7 volt. So you will going to get, it's guaranteed that you will going to get an output voltage of 5 volt, because the input voltage is always more than 7, which is minimum required. So to get this voltage at this point minimum as 11 volt, my V ripple should be 1 volt. So what is the expression for V ripple you have for half wave rectifier? So V ripple is given by Vp minus Vd on by Frc. Now we know this value of V ripple, which is 1 volt. We know what is Vp, we know what is Vd on, we know the frequency, which is 50 Hz. We can assume the value of R, the input impedance of this, as around 1K. Then we can find the value of C. So it is 1 is equal to, so what is Vp minus Vd on? So Vp minus Vd on is expected to be 12 volt divided by 50 into R is 1 kilo ohm. Then you can find the value of C. So if you find the value of C using this equation, then it is 1 alpha equals, make it as 12 divided by 50 into 1 exponential 3 into alpha A, close. So the value of C comes out to be 2.4 into 10 power minus 4, or you can write it as 240 microfarad. This is the value of C. If the value of C is 240 microfarad and the rating of the transformer is 8.9 volt RMS, then it is guaranteed to get the output voltage, which is constant at 5 volt. So now let us assume that, so we will going to have, because these are the design values, so let us try to use very close to this. So let me use a 9 volt transformer. Let me use a 250 microfarad capacitor. If you use this as, because these are the things what we expect to do. So this we already have it, and we are using a half wave rectifier. This is found out to be 250 microfarad. Of course, it was found out to be 240 microfarad, but we are using 250 microfarad. The rating of the transformer is found out to be 8.9. We have a closest possible standard value, which is 9 volt. If I use 9 volt, 0 volt and 9 volt transformer with a 0.7 volt drop with a 250 microfarad capacitance, can we find what is the actual waveform we're going to get it over here? So this is what Vp minus Vd on, and this is V. Let us find out what is for 9. If Vrms is equal to 9, this is a cross check of we have designed these values. If I put those values, will I get it back or not? So if it is so and so, what is Vp? Vp is 9 into root 2. So this will be 9 into root 2. I am getting it as 12.72. With minus 0.7, it will be 12 volt. So at this point you have 12 volt, that is Vp minus Vd on is 12 volt. Then we can find what is V ripple. So V ripple is Vp minus Vd on by FRC. So it is 12 divided by F is 50 hertz. We are assuming 1 kilo ohm as the resistance of your input impedance, and we are using 250 microfarad exponential minus 6. You can see the ripple voltage is coming out to be 0.96 volt, which is 960 millivolt, which is less than expected 1 volt, which is good only. So here it is 12 volt, and here you have what is 12 minus 0.96? It's actually 11.04 volt. This is the voltage that is available here. Because this 11.04 volt is always more than 7, is it not guaranteed to get a constant 5 voltage at this point? So I'll be certainly getting a 5 volt constant at the output of 7805. This way we can able to realize a DC voltage of 5 volt from a 230 volt AC 50 hertz signal. So requirements are this: you need to have a regulator because you are looking for 785 volt, it is 7805. If you are going with half a rectifier, you need only one diode. Then you are supposed to find the value of C. Because why you want to find the value of C is because when you just go in the reverse direction, this is 5 required minimum voltage. You know how much you get it, how much you want to put so that you get a constant 5 volt. Then you try to assume more than that. I need to have 7, so just keep more than 7. If we assumed it to be 10, even if it is 11, it is not an issue. So always try to have more tolerance so that you never end up in trouble in not getting a proper voltage. So upon solving all these things, we found that the transformer rating should be 8.9 volt, which we approximate to a next possible highest standard value, which is 9 volt. And then using this 12 volt as Vp minus Vd on, we actually found out how much is the value of C to get a ripple voltage of 1 volt. It was coming out to be 240 microfarad. We actually used 250 microfarad. Then we actually redid the design. So by having that transformer of 0 to 9 volt and having a diode of 0.7 volt to break in cut-in voltage, and used a value of C is equal to 250 microfarad, just confirmed ourselves, is the voltage at the input of regulator, is it anytime going below 7 volt. So it was found that it is always above 11.04, so it is of course guaranteed to get an output voltage of 5 volt without any issues. So this way we can able to very effectively design a transformer, a power supply, to get a constant DC voltage of 5 volt from an AC signal. I hope this will going to help you in just designing a DC power supply from an AC signal given the specifications. Of course, we can just do the similar analysis by considering a full wave rectifier also. Then what you need to have is you need to have 2 diodes and this expression will change. The thing is that here the expression will be for V ripple voltage is Vp minus, what is that, Vp minus Vd1 by 2 FRC, and of course the value of C will going to be half of this. So value of C will become half. But in case of full wave rectifier, only requirement is that I should have a center tap transformer. I should have a center tap transformer. So maybe you can just try out that. So let us do the second design for the same 5 volt DC. This is DC 5 volt from a AC signal of 230 volt AC 50 Hz signal. So again, I need to have 7805 as a regulator. I need to have a full wave rectifier, and I need to have a capacitor. Of course, I need to have a transformer. So these are the things I should have it. So let us write the circuit diagram. So we can start from the input side. You have this, then you have, of course, it should have a center tap transformer. This is my full wave rectifier. Now here you can see it requires 2 diodes. This is the circuit diagram. I'm going to have this as my capacitor. Make sure that there is no, and I'm going to have 7805. Okay, this is C. So the minimum voltage required is here 11 volt. Assume that. So the waveform what you are getting at this point is, it just goes like this. This is, I want this to be 11 volt, and let this be 12 volt. So this is what the capacitor voltage. If you say this as VA, this is VA how it looks with respect to time. You can see it's always because I need to have this voltage to be always more than 7, the input voltage, which we assumed to be almost 40% more than that. It is almost 11 volt, and we are assuming a ripple voltage of 1 volt between this and this. We can actually find out what is capacitor required. So what is this voltage, whatever 12 is nothing but Vp minus Vd on is equal to 12 volt, from which I can able to get Vp is equal to, now it's a 12.6 volt. Of course, as in the previous case, the VRMS happens to be 12.6 by root 2, which is 8.9 volt. So this should be 8.90, 8.9. Okay, this you can see this is the major difference. It's a center tap transformer with 0 to 8.9. This is 0 to 8.9. Here in the previous case, this was actually 0 to 9. Okay, ultimately we just end up with having it as 9 only, because 8.9 will not be available. It is 0 to 9 and 9. It's a 909 transformer. I need to have it. So this you can approximate it to 9 volt, and let us try to see what is the value of capacitance required. So V ripple is equal to 1 volt is equal to Vp minus Vd on by 2 FRC. Then this comes out to be because Vp minus Vd on is exactly 12, so everything remains same, but in the denominator you have 2 also. So it is now 12 divided by 2 into 50 into 1k into C. If you actually find the value of C comes out to be 120 microfarad. This is a major difference. The amount of capacitance that is required here in case of full wave rectifier is exactly half of what is required for half wave rectifier. For half wave rectifier, you need to have a capacitance of 240 microfarad, but here you can able to do it with only 120 microfarad. So let us have it as 120 microfarad now. So if it is 120 microfarad and if it is 909, so it certainly get. Of course, if you just work back, what is the voltage you're going to get it here? So because it is now this is 120 microfarad. If it is 120 microfarad, you are bound to get exactly 11 volt. And then if it is 9, so how much is 9 into root 2? So it happens to be, that's what we found here. It is 12.72. It is 12.72 volt at this point, over here, and minus of 0.7 is the voltage after your regulation, after the diode drop. So you are getting 12.02 volt at this point. So this is the voltage what you have at this point. The peak voltage is 12.02, and then you have a ripple of 1 volt. So suppose if I say what is V ripple with the value of C is equal to, this is now 12.02 Vp minus Vd on F Rc. So we know all the values of 2F and Rc. So it's now 12 divided by 2 into 50 into R is, we are assuming it to be 1K, and it is 120 microfarad. You can see it's exactly 1 volt. When I say exactly 1 volt, this ripple voltage is 1 volt. So the output voltage, the input voltage to this regulator is always minimum is 11, so that you're bound to get a constant voltage of 5 volt at this point, because the input voltage is always more than 7, which is minimum required. So you're going to get a constant 5 volt with this circuit. Only difference between this and this is you need to have 0 to 9 transformer. Here it is 909 transformer, but the capacitance value is reduced by half because you need to use 2 diodes. Here it is, the value of C is 120 microfarad. It is 909 transformer, 2 diodes. This way we can able to do the design using the full wave rectifier also for the same specification. Okay, I'll just leave it to you to do the design for using a bridge rectifier also. In case of bridge rectifier, only the equation changes here. This will become Vp minus 2 Vd on. Of course, you can still end up with only 120 microfarad, but only thing is that you may have to use only 4 diodes. The rating of the transformer could be still 090.